products and quotients of powers. So there are two key rules that we're going to learn today. One is about the product of powers, and the other one will be about quotients of powers. So when you see 5 to the third times 5 to the 8th, well, 5 to the third is 3 copies of 5 multiplied together, and this is 8 copies of 5 multiplied together. This is the long way. And in total, that's 11 copies. In total, that's 11 copies. So you can say this is 5 to the 11th. Well, what's the way you go from here to here? Well, you can just say 3 plus 8 gives you that 11. So the rule that we are learning is if two powers have the same base and are multiplied together, you can keep the base the same and add the exponents. So here, these are the same base multiplied, so you can add the exponents and get b to the 12th. Here, these are the same base, so we can add those exponents. X plus x is 2x. These are the same base. Add the exponents. Y plus 5. Here, these are the same base. We add the exponents. 11 plus y. Here, these are the same base. So we add those exponents. And these are the same base. So we add those exponents. Here, 8 and 3 are normal numbers that will multiply normally. I believe that's a 4. 4 and 2 are normal numbers that will add together. Negative 3 and 2. Again, this is multiplied, so we'll add them. These are multiplied. Negative 5 plus 2 is negative 3. And if you continue this problem using your integer exponent rules, this is 24t to the 6th over uv cubed. Okay. Our division rule. So if we see something like this, 5 to the 11th over 5 to the 4th, well, that's the same thing as 11 copies of 5 multiplied together, divided by 4 copies of 5. And if we continue this pattern, well, there are 1, 2, 3, 4 copies of 5 that cancel out. And we're left with 5 to the 7th as our answer. Well, how can we get from 5 to the 11th and 5 to the 4th to 5 to the 7th? 11 minus 4 gives us 7, and that pattern will continue. So the quotient of powers rule says if they have the same base and are divided, then you'll keep the base the same and subtract the exponents. So multiplying turns into addition, division turns into subtraction. So here, we're subtracting the exponents because they have the same base. Here, we leave the base the same, so it should still be 3. Don't do 3 divided by 3 and get 1. 6 minus 2 is 4. Here, well, let me make some more space for this one. Ooh, that's exciting. We want to add those to get a to the 3x. We want to add those because they're multiplied. B to the y minus 5. And now we can subtract the denominators. So here we keep the base the same, subtract 3x minus 11. And we subtract here as well. B to the, let's see, y minus 5 minus negative 8. Negative 5 minus negative 8 is negative 5 plus 8, which is positive 3. So y plus 3. And then here, when there's no exponent listed, that's an exponent of 1. So this is 3 minus 1 is x squared. Y to the first divided by y squared is subtracting those gives you y to the negative first. And z squared divided by z squared is 1, or the same thing as z to the 0th. So this is x squared over y, and z to the 0th is 1. So there's no copies of z in our final answer. All right, that's it. Thank you.